So Module 5 is on growth models, and growth models is something that you guys worked on in secondary 1 when you were looking at the difference between linear functions and exponential functions. And that's basically what we're going to do here. So it just talks about populations of people, animals, and items are all growing around us, and we have to understand how they grow in order to understand what to expect in the future. And they've used this with COVID and the numbers and how many people they think will be infected and how many people are going to die from it, and all of those things. There's two types of equations that we can use that might help us find those pieces of information. So the first one is a recursive equation. And if you think back to secondary 1, a recursive equation is one that you have to be able to know the previous value in the sequence in order to find the next value. So this one relates the next value to the previous value, and that's recursive. Explicit equation helps us know any value in at any time for whatever we're looking at. And so this helps us calculate the population at any time directly without having to know the previous value. So in secondary 1, you wrote linear growth functions, both recursive and explicit. And so if we think back, P sub n is what our value is at the end of a certain time. P sub n minus 1 is the value that happened previously, and D is the rate of change. So this is how it's changing. So this is the rate of change. This is your previous value. And this is the current, the one you're looking for. Okay. Again, as we look, you've got explicit formulas, and the explicit formula is a little bit different. You've got, again, P sub n is the value at a certain time, just like before. P sub 0 is your starting value at time 0. And the D value is the rate of change. And the N value is the time. And that's usually the part that we're going to plug in. So that's our variable part. So they talk about the first situation, which is, it says we consider a population that has an initial population of 70. So when they talk about an initial population, that's like our P sub 0, or our starting amount, or our previous value. And it says, and it grows according to the recursive formula P sub n minus 1. This part of a recursive is always the same. This part never changes. It's always this when you're writing a recursive. The 85 is the growth rate, okay, or rate of change. I'll just write growth rate. So as I look, it said, what is the initial population? That's that P sub 0. So our initial population is 70. And so P sub 1, I would take 70 and I would put it into this spot right here. So I'm going to do P sub 1 is equal to the previous value, which is 70. That's P sub 0 plus 85. And so we get 155. For P sub 2, then I'm really putting in the P sub 1 value, which is 155, and I'm adding 85 to it. Again, you're always looking at the value that happened before it. And so if you know that, then you can find the next value. But in order to do recursive, you have to know the value that came before it. So we add them together and we get, 240, not 245, 240. And it asks us what the growth rate is. And the growth rate, again, is that value at the end. So it's this 85. And so that's why I'm growing by 85 each time, but I'm using the previous value in the other spot. When I write an explicit formula, P sub n is always equal to the starting amount. So in this case, our starting amount was 70, plus our growth rate, and our growth rate was 85. And then our value here is just going to be n. So it's 70 plus 85 times whatever the time is. So if I'm finding p sub 100, I'm using that formula. I'm going to go 70 plus 85. Instead of writing n, I'm going to write 100, and I'm just going to do the math. So this is 70 plus 8,500, so this would be 8,570. And this is what they're looking for when time is 100 or n is 100, and you just plug it in. So as we look at example 2, the same idea. Again, it's either they're going to either tell you it's a linear growth model, like they'll tell you that, or they're going to say it's increasing by da-da-da once a month or twice a year or whatever it is. So in this case, it talks about a population of beetles, and they're growing according to a linear growth model. It says the initial population is 4 beetles. So this is your P sub 0. And it tells you the population after 10 weeks, so that would be P sub 10, is 114. And so we're going to plug it into, it wants you to find an explicit formula for the beetle population, but we have to know what the rate of growth is. So the easiest way to do that, if it's linear, is I can find the slope, or I just plug it into my equation. So remember, my equation is P sub n is equal to P sub 0 plus the rate of change times n. And we don't know the n, that's what, or the d, sorry. We don't know the d, we're looking for that part. But we can plug in the other pieces, and so we're going to plug this value. This is the n, and this is my amount, the P sub n. Okay, so the 10 is my n, this is my P sub n. So I'm going to put the 114 in here, and I'm going to put the n value, which is 10, in for n. And then we're given the P sub 0. The P sub 0 was 4. And so I'm just going to solve this problem like I normally would. So I'm going to subtract 4 from both sides. This gives me 110 is equal to 10d. When I divide by 10, then I get d is equal to 11. So that's my growth rate. So this is my growth rate, or my rate of change, however you want to say it. So when I go to write an explicit formula, which is what they're asking for, it's going to be P sub n is equal to my starting amount, and my starting amount again was this 4. And it's going to be plus my growth rate, which now we know is 11, and then times my n value, which is just going to be n. And so this would be my explicit formula. So then the next question says, well, after how many weeks will the beetle population reach 235? Okay, this is my P sub n. I'm trying to figure out what the n is where I get 235. So I'm going to take the 235 and I'm going to plug it into this equation for P sub n. So I'm going to go 235 is equal to 4 plus 11n. And then I just solve that equation. So I'm going to subtract 4 from both sides to get 231 is equal to 11n. I divide by 11, and we're going to get n is equal to 231 divided by 11, which is going to give us 21. So what does that mean? It means 21 weeks. It's going to take 21 weeks to have 235 beetles. So that's linear, and that's what you worked with linear in 8th grade, but you also looked at it again in secondary 1, comparing linear to exponential growth. And so when we talk about exponential growth, remember that exponential is when we are changing the growth by a percent or multiplying by the same number, where remember linear is adding or subtracting by the same number. Exponential is multiplying or it's changing by a percent. So either one. If the quantity starts at size P sub 0 and grows by r percent, and we always, and this is the key part here, always write it as a decimal. And then the quantity after n time periods can be determined using either of the relations. So notice again, you've got the recursive formula. This part is always P sub n and P sub n minus 1. It never changes. Okay, when we're writing a recursive. The r is our growth rate. Okay, this time our growth rate is a percent, or it's going to be multiplied by the same number each time. And again, we call that R value the growth rate. In the explicit form, P sub n, again, is going to be your value at time n. P sub 0 is still your starting amount. R is your growth rate. And n is your time, just like before. The term 1 plus R is called the growth multiplier or common ratio. So you're going to see that come up. Make sure you understand or you're aware of that terminology. So it says, suppose there's a lake that contains 1,000 fish. Okay, this is what I start with. This is my P sub 0. It says each year the population increases by 10%. Whenever you see that percent sign, you know that it is going to be an exponential growth. That R is going to be 0.1. You always want to change it. And remember, we change it by, my decimal point is here, I move it over 2 places. So that's why we've got 0.1 instead of 10. So when it says, what is P sub 0? P sub 0 is what I start with. So my P sub 0 is 1,000. If I'm doing P sub 1 and I'm using the explicit, or the recursive, sorry, because I can find just the next one, then I get P sub 1 is equal to the previous value, which is 1,000, times 1 plus my rate, which is 0.1. And so I just multiply that in my calculator, and I just go 1,000 times, and you can either do 1 plus 0.1 or just put it in as 1.1. It's kind of up to you. But then this is 1,100. And if I'm finding P sub 2, then I have to take the P sub 1 value. That's what goes in this spot, which is going to be 1,100. And again, I multiply it by 1 plus 0.1 or just 1.1. It's up to you how you choose to do that. So this is 1210. If I'm finding P sub 3, the same idea. So for P sub 3, you take what you got here, the 1210, you multiply it by 1 plus 0.1 or just 1.1. And again, that's up to you. So this is 1331 and so forth. So then P sub 4 is going to be 1331. I'm just going to write it as 1.1 now. It's easier, which is going to give me, and this gives me a decimal, 1464.1. Now, when you get that, you may have to round it to the nearest fish, or they might just have you round it, so it'd be like 1464. P sub 5, if you put your value in, and we get 1.1. And again, just be careful, make sure you're reading what they want you to do. So this is 16.51. So this one, if I was putting it in the computer, it'd probably have me say 1611, and this one would probably have me do 1464. Just kind of be aware of that. Read your question carefully. And then this one talks about between 2007 and 2008, the population of Olympia, Washington grew by approximately 3%. So again, that helps me know my rate. And so in this case, our rate is going to be, if I move it over 2 places, it's going to be 0.03. And this is my initial population, so this is P sub 0. And it says, if the growth continues, what will the population be in 2020? And so I have to know how many years it is from 2008 to 2020. So this, comparing these two, that makes it so n is 12 years. And then I just plug it in. So I'm going to write an explicit formula. So remember, when we write our explicit, it's going to be P sub n is equal to P sub 0 times 1 plus r raised to the n power. That's our explicit formula for, an exponential. And we just plug everything in. So P sub 0, this is 245,000. This is 1 plus 0.03, and we're raising it to the 12th power. And you're just going to put it in your calculator, just like that. So let me move that. So we're going to go 245. And again, you can just put it in all at once. 1 plus 0.03. And then you're going to raise it to the 12th power. And so that makes it so I've got 349. So 349,311. You have some decimals, but we're talking about population. So we just want to round it to the nearest person. And so this would be my population. For example 5, it talks about a friend is using the equation P sub n equals 4,600 times 1.072 raised to the n power, and it wants us to predict the annual tuition at a local college. So she says the formula is based on years after 2010, and what does the equation tell us? And so just looking at it, it wants us to try to figure out what this means. And so the 4,600 would be your tuition in 2010. And then if I move my decimal point over 2 times, the 7.2, or we can write it like this, the 0.072 means that my tuition is going to raise 7.2% each year. And that's what I can tell from that problem. We're going to stop the video for this one, and then video 2 will go over the rest of it.